we'll go back to the live. Of course, they can all hear me doing this. Again, the beauty of live webinars.
Stuff happens.
Wrong button. So we'll try that again. We'll do it again. Now, all I want you to do now is just go back to the slides.
Slides.
There we go. And now here we go. Now, that's all you have to do. You're all set.
Don't touch anything else.
We're word from our
Ready to push.
Oh, right. Hey, I hope you guys enjoyed that. We're not 100% sure. Nobody said anything about not being able to hear the audio, so I guess it all came through okay for you. I hope you enjoyed that part. Of course, our sponsor is indeed Mitchell One. Has made this possible for us tonight. So a big thank you to them. If you
Yes,
guys,
and welcome back.
yeah, because this is this second or third one. This year
Maybe the
we've
third
done
one
with
this
them.
year.
And as we always let you guys know when we do these webinars that are sponsored by these different companies, they're doing this, sure, to get their name out there, but they're also doing it because they really want to help you guys and gals have a little bit easier road to hoe when it comes to servicing these vehicles. And we're going to be talking about something kind of unique today, right? And that's the electric vehicle dealio. Before we get started, some usual routine webinar stuff. I know we've already got a copy of some guys talking about that. No, the link on the player page does not work, and I apologize for that. We will put together some kind of a handout for you and put that on that site. So when you come back in the next few days, it will work and you'll be able to download it, okay? So give us a little bit of time to put that together. The slides tonight are pretty generalized. So it's not going to have all the information that we would like you to have at hand. So I think you'll find that if you give us a few days to put something that's going to be very informative for you, because we were working right up to this to the very last minute to make sure it was really good for you. We'll get that information to you. So like I said, you just keep an eye, keep back in a few weeks. That link will be hot and we'll have something there for you. Okay. Questions, when you go in the chat box, that's where you can answer your questions, offer your comments. Please try to keep it relative to our topic tonight. I'll give you another alternative for that if you have something else on your mind. And don't forget, when you go back, if you go back to your account page that has the class listed, right where you click through to come watch it now, when you're done, you'll be able to go to that same page and you'll see the click here to download your certificate of completion. So if you're an educator, you will need that for your continuing education credits. You can use it for that. And if you just want to show the guys in the shop that you are a professional who's trying to maintain their level of professionalism by attending training, then you can use it for that as well. All right. Or email us. Like I said, if there's a question that comes up afterward that hits you and you want to know, or there's something else that we can help you with. We've said this many, many, many times. We started doing this not for fortune and fame. We started doing this because everyone in this room, including Ms. Doreen, knows what it takes to make a living in this business. The three of us, well, maybe Ms. Doreen too, has the battle scars and the t-shirts to prove it, right?
Just to put up with me. That's a battle scar.
We want to make sure that we can do all we can to help you have a little easier way of it than we did and to help you make a better living and take better care of your families. That's really what it's all about for us, okay?
No doubt.
Okay. So let's talk about EVs in general. And if you can open up the camera a little bit there and kind of pan a little bit to my right. And you can see that there you go, the little red Tesla Model 3 that I was driving over here today. I want to suggest something to you guys. I want to think of an alternate reality. Here's first is a trivia question for you. I'm sure all of you know the name Wells Vehicle Electronics. They've been in business for hundreds of years. And they have known for ignition system components, engine management sensors, actuators. That's the bread and butter. Now they're part of NGK, I believe.
Yes.
They've been around for a long time. And when I first started with the Motor Age, I had a chance to go visit their headquarters in Wisconsin.
Fun to lock.
Yeah, fun to lock. And it was really cool because they're still in the original building they started in. So there's a lot of history there. So I have a trivia question for you. And let's see if any of you guys know the answer to this. What do you think the first product that Wells Vehicle Electronics ever made was? Right? So I'm going to give just a minute. And I know there's a slight delay here, so we don't want to avoid too much dead time. But if anybody has some ideas about what was the very first thing that Wells Vehicle Electronics made. Of course, now you remember this is in the early years of the automobile. So a lot of possibilities. We got any takers there?
Not yet,
here?
but there is, it takes time.
And actually, having been there myself, that little town that everyone knows, it's like Mayberry. Everyone's like, who's that guy?
Right? Yeah, it's a very small town.
Somebody
So-
said turn the volume up. They can on yours, Pete. Is that possible?
Volume up?
Somebody
You
can hear
just lift that up
They
a
can
bit.
hear Jerry well, but not you.
We can switch mics if need be. Can I hear him now?
See if that's better.
Is that better?
They're both
Somebody
set.
wrote points, electric motor, points, spark plug, points. They thought
Maybe if I
points.
take it off of mute, that will help.
That's
That's better.
Anyway,
oh,
So you're hearing me on G's mic.
oh God.
okay, that should be better. Anyway, points, electric motor, points, spark plug wires. we shall
Okay,
watch
so
them.
everybody's coming up with ignition-related components, and Mr. Green is holding their close to her head. No, the very first thing that they made was a wiring harness for an electric car. Very first thing they ever made, because electric cars were on the scene before the gas engine cars were, believe it or not. And the rich folks liked them because they didn't have to crank anything. That it wasn't noisy and smelly, and it wasn't dirty.
It wasn't dangerous. Crank
It
in the
wasn't-
old
yeah,
days,
So
get hurt.
that was one of the first cars made. So let's consider this alternative reality. Let's just say that this little red EV behind me was the norm. Let's just say back in those days, the battery vehicle, the electric vehicle, actually won out over the ICE and became the way that transportation grew and developed over the last, 100, 200 years? 100 years anyway.
120,
About 120, 30
So a
years.
long time, right? And now we jump forward from those early days. Henry Ford did a great job of making electric cars affordable for the masses, and it
Gas cars.
came out with the Model E.
Yep.
So the Model T,
I got you.
right?
Yeah.
Okay, so everybody's driving electric, but now we come fast forward to now, and now we're looking at climate issues, environmental issues. The tree huggers are all telling us how the battery vehicle, the electric vehicle,
static on your line.
static on my line.
Go ahead. Keep yakking.
Anyway, the electric vehicles, making the batteries is
On them.
It's on them.
okay, making the batteries takes a lot of fossil fuel to do the mining, to get the raw materials, the production lines, polluting the atmosphere, and then we've got the batteries when they're worn out, and how to dispose of them.
That's
creating
ground
issues with
pollution.
landfills.
Oh yeah.
So it's the big thing. And then here comes this guy named OTTO. And he comes up with this brand new, low emissions, fossil fuel vehicle that uses something called an internal combustion engine. And the beauty part is
I don't have to wait.
there's no range problems. I can fuel up in minutes instead of hours and be on my merry way. And the impact is so much lower than everything that's going on with this battery. And everybody's going to look at that and go like, wow, that's the neatest thing since sliced bread. It's so cool. We all need one and want one. And the politicians are going like, yes, we need to do special inducements so everybody buys one of Otto's gasoline-powered vehicles for the environment. That's one of the things I wanted to point out, guys. EVs are here and they're coming and they're not going anywhere for sure. And the reason, who knows? But that's not going to be the only answer. There's always going to be some eclectic mix, in my mind, of transportation modes. All of them have to help us reduce what we're pumping into the skies. There's no question about that. The CO2 that we pump out will stay in the atmosphere for 1,000 years. So we can't continue to let it build. We will reach a point of no return.
Right.
So anyway, with that said,
But you should tell them on the range here. So Pete plugged in with level 1 charging
the
the whole day since you've been here. 110.
Right? Yeah, and I think in the 6 hours that I've been here, I've come up about 8% on the battery, right? So that ain't gonna cut it.
So, just a quick little story. When we were on vacation going down to Cape May, New Jersey, we had the absolute range anxiety. Now, our electric vehicle told us we're going to get there without a problem. And barely made it. But what happened? It was super warm out. It started to rain, okay, and it was windy. So what do you think happened to the range?
Yep.
And that's what they call range anxiety. Now, there's two good things I want everyone to say. There's a Ford F-150 Lightning versus a GMC pickup truck, both pulling a trailer. The range went because you plug in what you're pulling, the length, the weight, and went down. That was originally on SAE. You can catch it on YouTube now and Facebook. The other one is two girls that write for the Wall Street Journal, bunch of tree huggers, were all excited to get into a Tesla. And they were saying how good it is, how clean it is. Well, they had the worst time in their life leaving New Orleans to go up to Chicago. They had a hard time, people waiting on lines. You know, it's that range anxiety is real. I can tell you that for a fact.
Yeah.
It's real, and there's not enough. In fact, GM put a release out yesterday. They sent me a special email. Now they're going to make every GM dealership in the country have EV level 2 charging. That way, they say each person that lives in the U.S. is within 20 minutes from a GM dealer somewhere.
Mm-hmm.
Now, I can tell you in Alaska, that ain't real.
Yeah. Yeah.
But most places, I guess.
But if you think about that, look at the analogy that I just made. What if it were the other way around? We'd be talking about gas stations,
right?
You know, fueling centers. The infrastructure has to be built,
right,
one way or another. And I think everybody has kind of an opinion of how it's going to happen. It's going to happen.
Oh, it's going to happen.
It's going to happen.
But then again,
you're still looking at a couple of hours that you're sitting there waiting for to replenish, right? Or and we're going to talk about that when we get the batteries, of how these different charging levels and the impact they have on the longevity of that battery pack.
But then again, you know, like the great Governor Newsom, he's telling you, you know, you can't keep the lights on in your house if you charge your car. So you and I will be here on bicycles, cycling to try to get the electric level up so we can broadcast.
Yeah, we saw that. Yeah, that tickled me too.
And we're not in California; we're in New York. But
so let's get to. We all came here to learn about what we have to do to bring these into our service shops, right? So we'll go away from that and we'll go back to the real world and leave our alternate reality and talk about this. All right, the first thing I want to share some information on just what can you truly expect? Because right now, EVs don't make up a huge part of the market. I did see a little interesting stat while doing some diesel research and found out that hybrids are outselling diesel trucks, which is, if you're from down south, you kind of raise your eyebrows up because the Americans love their pickup trucks. Trucks are the number one selling vehicle in the country, right?
Yeah, I think F-150 is still number one.
Absolutely. And of course, now a lot of them want their diesel-powered vehicles, but hybrids are starting to increase and more and more and more. As you can see from the graph of what the expectation is, I mean, 2030 is not that far off. We're looking at about a 20% market penetration. In other words, 20% of the vehicles on the road, that's 1 in 5 guys and girls, by 2030 will be hybrid or electric. And then 5 years later, you're looking at somewhere closer to about, what is that? 40%.
Yep.
And then by 2040, 76%. And it's just going to continue to grow from there in terms of penetration. Now, why is this the case? That's the interesting question. Yes, there's the climate control issue and fossil fuels to get rid of those and all that kind of thing. But the factories, in my mind, are doing it because of something you've heard us talk about before, and that's the CAFE standards, or the corporate average fuel economy numbers. They have to meet. They have to hit like 54.5 by
2025.
Yeah, which is what year are we in now?
23.
So we're only a few years away from this deadline. So if the manufacturers can get a bunch of EVs and hybrids into the marketplace, it's going to help them offset the mileage numbers that are coming from the big old pickup trucks and help them reach that goal. So that's where the big push is coming for those products.
And, you know, one of the things Toyota just put out, they're going to go to EV, but they're not getting rid of their hybrids. Obviously, no one sells more hybrids than Toyota Motor Company. So it's interesting. I think the reason they're looking at is, again, the infrastructure is not there. This is putting the cart before the horse. Mm-hmm. This is what we're doing with this EV market. We do not have the infrastructure, not because I say it or Pete says it. You look at SAE, Society of Automotive Engineers, and the high voltage problems that they have in this country. Our system is totally backward. Yeah. Even being in Texas a couple of weeks ago. Remember what happened a couple of winters ago in Texas? and they got windmills because that guy Pickens, the billionaire, he put all of these windmills up and stuff. They still didn't have the right infrastructure. A little ice storm came, and when they cut back from generating with petroleum, they had a problem. So petroleum is going to be here for a while, in my opinion. I'm not an expert, but I'm just going by what the experts say. And every gas station is going to need to have charging ports for the simple reason, like you said before, you could fill a gas or a diesel up in what, 15 minutes, probably?
Not even that.
Not even. Well, let's say you got a huge tank, like my motorhome. So it's going to take a while and make me broke.
Yeah.
But besides that, when you go to charge a vehicle up, even at level 3, you're not getting 100%. And that is not good on your battery. So we'll talk about level 1, 2, and 3 and which way is the best thing to charge your vehicle.
Absolutely. Next thing I want to show you, and you just pointed out about Toyota wanting to stay with their hybrid models, and they're the biggest seller, but there are a lot of people entering the EV marketplace. You're going to see companies, startup companies that are already out there. And that's something I want you guys and gals to understand as well. We're not talking about just passenger cars, light trucks. The EV is going across all of the different transportation sectors. Right now, there are agricultural combines out in the Midwest that are EV, autonomous, and out there plowing fields using GPS. And all the guy in the cab is doing is sitting in the air conditioning watching the ball game. Go Houston! No.
Hey, watch it. You're in Yankee territory.
I had to say that.
We're behind too, so it'd be nice.
Mike says, Mike Williams wants to let you know that you better not let the Houston beat you guys. Anyway.
Okay,
So
we're trying, Mike.
Inside joke there. But again, this is not science fiction anymore. It's not what's coming tomorrow. It's here right now. And the beauty part of it is if you embrace the technology, it's just imagine what you were doing when you first learned how to work on a gasoline engine. It's a whole new learning curve. You got to start all over again and learning how these things work and what to look for when they're not working the way they should. Good question for you. If you were a fleet technician for UPS, which they have a fleet of electric vans, delivery vans, and the manager wants to know how come this boy is always kind of running out of juice before he finishes his route, but this guy who has a similar route in the same van, the same load, has actually got power left over when he comes back to the shop. He's going to come to you and say, well, why is that? Can you answer that question right now? If not, then we got some work to do, right? We all have some work to do in learning this new technology, right? And this is why it's coming at you hard and fast. And what's the other exciting part? If you're good at diagnosing and taking care of these EV systems, these high voltage powertrains, you can go to any transportation market you want. You may be in passenger cars today, but maybe you decide, well, hey, I want to go into aircraft. Guess what? They're looking at EV aircraft.
Delta flying something.
They already have some
experimental
prototypes. Class A tractors, Freightliner, Kenworth, Peterbilt, all of them have EV models that are not, it's not too far before they'll be introduced to the general public.
Yeah, John Deere is actually using quite a few electric. Some of the problems are they can't finish plowing the fields per se because the battery went out. Now what do? You need a special backup machine to go out there and power this vehicle up.
Yeah.
So there's some quirks that people don't realize. Well, I ran the diesel all day from early in the morning. Well, this is not your diesel.
Yeah, and like you said, right now, of course, the Tesla that's sitting behind me, they're the number one right now in EV vehicles, of course, but they're not going to be for long because just take a look at this. Between 2020 and 2024, it's just a little bit older data. So by next year, there'll be 90 new EV models released. EV startups growing by leaps and bounds. Major OEMs saying the bulk of their models will be released by 2024. So you're going to look at this wave of stuff coming at you in the very near future.
Right. And in some parts, you have Rivian there, which is, pretty big in many areas of the country.
Yeah.
So you're going to see a lot of names that maybe, you never heard before. Like the old days, Hudson, Packard.
Yeah.
Right. A lot of these people try to come out and then they disappear.
Yeah. Yeah.
They disappear.
I thought this information was really interesting as well because I still mean, and hybrid vehicles, electric high voltage systems are not new by any stretch of the imagination. This is technology that's been on American highways for 20 some years. when the first ones introduced, the Honda Insight maybe its debut, and then right behind that was the Prius, and they've been around for 20 years. But it's interesting when you look at the statistics of what common service items there are between hybrid and ICE or internal combustion engines. And you can see right here, big 33% of hybrid repairs are brakes. Same over here, 33% brakes. Okay. I think the one that caught me was like basic engine on the hybrid. A lot of work there. Body work, wheels, alignment, tires, HVAC. All of these are common systems that you're doing already.
They're working already.
So there's a lot of, even the Tesla has a lot of these basic subsystems that still need normal routine maintenance, right? And just as a side note, I got to give these guys a plug. Write this down. Oh, wait a minute. Grab your pen and pencil, or open up your notes on your phone or whatever. Write this down. It's www.N as in November, A as in Apple, S as in Sam, T as in Tom, F as in Frank. That's the NASTF.org. That's the National Automotive Service Task Force. I want you to go to that website when you leave ours, right after this is over. And I go to that website. The first thing you can see is a join button at the bottom. Click that button and join. It costs you absolutely nothing.
Correct.
And it lends your voice to what they're trying to do. And that is to be the intermediary between us and them being the OEMs. You can find a lot of great information on there. You can access the factory service information sites there. A lot of great resources available to you on that website. And most importantly, a lot of the things that we take for granted in terms of service information and access that we have is under the gun right now. And you need to protect you and your business and your business's future by being involved and being informed about what's going on in a legislative position so that you're not shut out before you realize that the door's already been closed on you. All right.
No doubt.
All right. So very interesting. There's a lot of things that you can do here. And here was even more interesting. The most common customer complaints, again, between hybrid vehicles and gas-powered vehicles. For example, here's the Leaf versus the Sentra. Number one on the list for the Leaf, engine does not start. And the orange is for the Sentra, engine does not start. Let me ask you a question. All you guys know right now what to check on the Sentra to see why it won't start. Do you know what to check on the Leaf to see why it won't start? How would you handle that situation? What would you do?
You hope a good wind comes and the leaf starts blowing.
Same thing over here. We take a look at the Volt. Engine does not start. Most of the complaints, and then again the Cruise does not start. I just want you to think about that. It's like if we were back to that alternate reality and we're all used to EVs, and all of a sudden here comes this guy named Otto, and let's see who can tell us why I'm using the name Otto, O-T-T-O. Well, here comes this guy Otto with this new fangled gasoline powered contraption that, I'll never see any of those. I'll never have to work on any of that. I'm going to keep working on the electric vehicles. I don't need that. And then once those up at your shop, can you see where I'm going with that? The learning curve that you're facing. It's a lot more than what we can give you in one webinar, but we'll point some resources out to you near the end that will help you with that learning curve.
No doubt.
All right. Now we can get to the meat of tonight's matter, and that's handling concerns that are related to EV systems. The first thing that you have to do in any troubleshooting or diagnostic is know what the heck it is that you're working on, how the system functions, common things that go wrong with them. And I have my master here, Obi-Wan, who is going to help you learn more about those components that are involved in the HV high voltage powertrain. And we're going to start first with a note on safety. I'll let you handle that. You're the man.
Safety, I'm sure you're so tired of hearing it, but you know what? Your life really matters. And if you don't have PPE, personal protection equipment, okay, that has been tested and certified, class 0 gloves at 1,000 volts, with covers, with a bag, with glove dust, and proper training, you can get potentially hurt or get killed.
Yeah.
Okay. So we always want to make sure you can go back to a different webinar. We're not going to waste your time on that, but we do want to mention that you need the equipment. Also, you should go and Pro Demand. You can go into Mitchell Pro Demand. And when I don't know something, I wish I knew everything on every car. I don't. So what do? You RTFI, you read that freaking information, go into system description. Why? Because if we're on something like these motor generators here, and you want to test something, okay, you want to test those babies, well, you're going to need to know, where do I set my meter at? How am I going to know this works? And the meter to
Yeah,
use.
what tools you need.
Yeah. So there is a learning curve. And, this is why a lot of hotlines will not help people on hybrids, extended range, which is basically the volt and some sort of plug-in hybrids as well, and an EV. They're really all the same, Pete. They all produce electricity from a battery, DC voltage, high DC voltage, going into the inverter that is going to change it with IGBTs, integrated bipolar transistor, to DC to AC. Why? Because the motor is an AC motor. And this is something very similar that we've seen before in an alternator, right? Got 3 phases, U, V, and W. It has to be rectified so we can get that in. And then we'll talk about, well, what happens to this AC? Our battery may be, like this is somewhere about 400 volts or so, but those motors are going to need 6, 7, maybe 800 volts. Well, how are you going to get that from a battery? We need to boost it up. I always relate it to, how do we get on GDI 65 volts when only 12 volts comes in there? Well, we use a boost transformer. We use capacitors, okay? And that is going to boost that voltage up so that particular component can work properly. And then we talk about, safety-wise, 5 to 10 minutes every manufacturer tells you to wait. Well, if you have the right equipment, you can test, and maybe you don't have to wait. But how do we drop that voltage that is in basically those capacitors? And a lot of these capacitors, minimal is 450 volts, and there's 3 of them, 1 for each phase, okay? So that's a hell of a lot of electricity. That'd be like if you shorted one of those out with all special equipment. I don't recommend doing it, but it would sound like an M80 going off, okay? Because there's a lot of stored energy there. And when you let stored energy go, something's going to happen, okay? This is just like, some people, and Pierre's been doing this for years. Sometimes you got to reboot your computer, which I had 2 problems with computers that had to reboot. So what do? You disconnect power. In the old days, you would take the cables off, the battery with the key off, and just touch them. Well, nowadays, it's similar, but you don't want to just do this, because this is why we would have a problem arcing something out. So we use a 1 ohm 10-watt resistor to bring everything down and drain all the capacitors that are in a computer.
Yeah, and let's stress, because I don't want anybody to be confused with that. She's referring to the 12 volt that's powering the module.
Correct.
No, I'm referring
to
that 400 volt
Very
battery
good.
pack. No. Don't put a 1 watt 10 ohm resistor between those leads. Make that very clear for you guys.
Very good. That's right. The brain was going to the 12 volt system. And by the way, when you put a battery in the vehicle, now most of the 12 volt batteries are going to be somewhere in the interior of the car. Okay. Not all of them, but a lot of them. If they're under the hood, it can be a regular flooded lead acid battery, 12 volts. Okay. That's the 12 volt system. We need that, and I'll explain that in a second. If it's inside the car, the only thing that is recommended to use is an AGM. So make sure you always look up again. Where do you find that? In service information. Okay. It's going to tell us that. And why is that so important, that 12 volt system? Well, Pete, we never can switch the low voltage side to the high voltage side. We have something we call relays. We'll use the Toyota term since they're number 1, SMR, system main relay. Now, why do you have 3 relays? Because when we switch from that low voltage to that high, if we don't use what we call a pre-charge resistor, we're going to arc those points in that relay, right? They're going to stick from pulling it on, pulling it off.
Yeah.
So we have 3 relays for safety. And again, here's where the brain, the eyes, the ears, the nose, the hands. If you shut the music off, you may hear click, click, click. And that's really what's going on in that vehicle. So we're going to take the low 12 volts, bring it up to the high voltage, whether it's 300 volts, 400 volts, Most electric cars are near the 400-volt range or so, okay? 360 and up. So that is something you should be aware of. But then when we have all that voltage and we shut it off, similar going back to the 12-volt system, we got capacitors in a regular PCM, okay, or a high voltage PCM. We have those capacitors that need to be drained. I told you what to do on the 12-volt side when you have a problem. The high voltage side does it itself. It has a special resistor grid to drain those capacitors down. We also have something, if you're going to take the ASE L3, highly recommend it, because again, some hotlines will not help them, okay, unless they have the proper training. Also, if you're on any of the European software, ISTA for BMW, Otis for Volkswagen, Audi, Enstri for Mercedes-Benz, Vita, and I even see it now on Ford, saying if you're working on high voltage, you need the right training. That doesn't mean you're listening to Pete and I here. You're going to need to get your hands in it. Mechanics are good hand learners, hands-on, okay? You could hear and read everything that's out there. Doesn't mean you really know everything. And this is a high voltage problem where someone can get hurt in a safety thing.
Yep.
And this is not like taking the power probe, and we've all done this, or a similar tube and go, tool, and just touch it for a second. You ain't touching this for a second, you're going to get hurt. In fact, one guy that used to work across the street, right from where we are right now, he's blind in one eye because he poked an orange wire. Lucky he's not dead.
Yeah.
Okay?
Yeah.
So you need to know how the system works, what to expect, and have the right training and the right equipment.
Yeah. And I want to kind of mention this now too, because we have both seen this. First thing I want to say is a little bit of knowledge is a dangerous thing. When it
Yes.
comes to the hybrid technology, we're giving you some foundational building blocks, okay? But this is not going to make you a hybrid drivability specialist, all right? It's going to take much more than that. And as a tech, you know how long it took you to reach that level of expertise with the gas engine, and you grew up with those. I really want to stress this because we've personally seen guys who are working on a high voltage system and they're not wearing gloves. They're not using the tools that are rated for that system. They are begging to get permanently injured. Guys, a little bit of knowledge is a dangerous thing. We're going to give you these blocks and we're going to help point you to resources to get the more complete package. But like G said, you can't get all this out of the book. And that's why I want to mention something too about the L3. The L3 will test you on your technical knowledge of these components and so forth. But again, having an L3 does not make you an HV expert. That is, you just relate it to your own experiences and how you came up as a tech. You were not born a great tech. You had to work hard to learn, to go to training, to develop those skills, to get that experience in order to get to the level that you're at now. And if you're a younger tech or fairly new tech who's watching, listen to what we're trying to tell you here, because we don't want you to get hurt, and we want you to have a long and fruitful and rewarding career, as a professional technician. Because it's been good to us, and we know it can be good to you guys. That's, again, like you said before, the tools that we're trying to give you. So again, safety first. We're not the guy who runs the corporate headquarters and comes to your store every 6 months to preach it, because they don't want to see their health insurance or liability insurance go up. No, we're telling you to be safe because we want you to go home to your families in one piece.
You bet.
All right. Hey, we've got a plug here for Mitchell One Pro Demand. A lot of you may have seen the notice for the webinar on your Pro Demand system, and we thank Mitchell One for that. They're being such a great partner. But they got your back when it comes to the EV information too. In fact, of the 8.5 million hybrids on the roads today, they have information to cover 7.5 million of them. So they have almost 90% coverage in their database, and they're working on the other 10. To be quite frank, that's part of the Tesla market. It's a huge market to get those involved. And if you're not aware, thanks to the folks at
NASTF.
They've opened the door for that, and Tesla has now made a lot of their factory information available to the aftermarket repair facility. But again, just because you can go on the NASTF website and access the Tesla service site and download the Tesla software does not make you a Tesla expert, okay? But it is a beginning. It
Right.
is a beginning.
And the number one thing that I see all these years in the industry, people will replace batteries because batteries is a high failure rate.
Mhm.
And they'll do it without any training. No gloves. If something happens, you're not going home to your family. So you really should do things the right way.
Yeah.
And we've all
we all get
made
lucky.
mistakes in the past. If this is not a mistake you're going to come back from. DC will suck you in and you'll be in big trouble.
Yeah. And you might be lucky to this point, but
Right.
that's it. It's luck.
Do it right.
Just real quick, we're all kind of familiar with the basic outline of the hybrid vehicle, where it's using that internal combustion engine as its primary power plant. Why do we call it a hybrid? Because it has more than one way to move those drive wheels, and how they act and how they operate. There's a little variance between manufacturers, different type of systems. Say the Volt is different from the Prius, and that's different from the BMW. So there's some nuances to it, but they all have the same basic high voltage powertrain components. So that's why we're focusing on that. And then conversely, you have the pure electric vehicle that you see here. And that's not a joke. You guys can see how big that battery pack is. It needs it if it's going to get that any kind of range to it, right? And just give an example. I picked up the vehicle I'm driving, the Tesla I'm driving, from a local airport, and I think it took me, I don't know how many miles I put on it, but maybe 75 or so.
Yeah, probably 30 from there to there.
Yeah,
to where you
so
were.
and I dropped the battery charge about 30%.
You know what they tell you? You don't know how to drive.
Yeah, right. And that could be
You're
a
consuming.
part of it,
Yeah.
right? Remember we talked about being the fleet mechanic. You might want to say, how's that guy driving that van, right? That plays a part of it, right? Okay. Now let's get into the meat of the matter. And again, I'm going to turn the floor over to my friend because he has. I don't know if you guys knew this or not, but Mr. Truglia is one of the first, if not the first, to create hybrid trading opportunities in the aftermarket for his customers. So I can't think of anybody better to bring that information to you guys tonight. Not telling his harm because he's a good friend, but the reality is the same. If a man's an expert at something, a man's expert at something. So it's all yours, my friend.
Thank you. So the high voltage battery obviously is the heart of the system, but what is that connection point again? The 12-volt battery with relays either internal here or external have to be switched on from the 12-volt side. Now, whether this battery is like on a Prius, 201 volts, and then boosted up to 500-600 volts, same thing on the EV. Everything's going to be the same. That skateboard that you had here, this is called the skateboard design, where the battery is really all under this Tesla here. One important thing, and another reason to go back to Pro Demand, is look at the lifting points. You do not want to go, oh, let me kick it under there, it'll be fine. You do that, we got a problem. Because these batteries are cooled by sometimes engine coolant and air conditioned. And if you break the seal in the battery, you're going to have a problem. Okay. A very bad problem.
And a very expensive
And
problem.
very expensive. I mean, these batteries can go for $30,000+. Okay. So one of the things that they're doing is Ford Motor Company, okay, Mercedes-Benz and GM are all using special testers with special plugs that you have to put into that battery pack. And then you're going to run this test from one is a purified air machine. It looks like a smoke machine, and never, never, never use any oil like through a smoke machine. You're going to need this purified air type of machine with a flow bore.
Why can't I use my
Well,
that
you know that oil will get in there and destroy that battery. And nowadays, air conditioning is not like, well, it's near the end of the summer. Well, summer's over. Okay.
for some of us.
Yeah, for you, that's right. You can still sweat down there. I was just sweating in Texas and in Arizona. But at any rate, we need to test that battery. Okay. If that case cannot be sealed properly because someone put a lift under there, someone put a jack under there, this is where we RTFI read the freaking information of how to put it up. Do not leave this to a novice to do this. We're going to run into a problem. Okay. So the battery has to go through a flow check. Okay. And our buddy, Bernie Thompson, is working with General Motors they're going to use the CO2 method because it's a smaller molecule. And if you're familiar with bullseye, well, they could find leaks anywhere
Yeah.
on that battery, and it makes total sense to do that. Flow Dynamics is the other company that makes the little machine. Doreen, do you know what that machine is on the table in there? The little machine, we can show them.
And while she's looking, Doreen's going.
It's a
after
red
that-
machine up front.
While she's going after that, I just want to say something else too. Oh goodness, what was it?
Here?
Related to the No, it's related to the battery testing you're talking about. He's going to go and
I'll get it. Go ahead.
Yeah, we're going to go into it more. But I want you to think about it. It's a battery. Just like a small battery. Video.
It's okay.
Like Mercedes, but it's not too far fetched from the truth. All these batteries are made up of these little individual cells, and the high voltage systems get extremely hot. So if we have any issues with lack of cooling, this could almost be a safety hazard to the occupants, right? These are lithium ion batteries. Do you remember the issues that some PCs had not too many years ago with the batteries catching on fire when they were being charged?
Sony.
Yes. So, I mean, it's like, again, this is what we're looking at. It's not, if you're not informed, if you're not fully trained, then you gotta shy away from something.
Yeah.
You can read the information, like G said, and a service like ProDemand will help give you a lot of that. But guys, and I'm not knocking anybody who's watching, I'm sure preaching to the choir, but we are reminding technicians on an almost daily basis when they call us and ask us questions, did you bother to read the service information for that vehicle that you're having a problem with? Did you read up on how that system operates, what that DTC is defined as? Did you look for technical service bulletins related to the issue before you called or emailed me or Mr. Truglia? And I don't mind, guys. You send me that. I'll keep right on doing everything I can to help you. But this is very, very important. And I'm going to interject this real quick, and I'll let Mr. Truglia get back to it.
I'm feeling older than I am.
I've been saying this a lot lately, and this is the perfect arena to say it again. The vehicles that you are working on and the vehicles that are coming in the next few years are the most highly advanced, highly technical marvels of engineering that the automotive manufacturers have ever produced. And they don't want to be fixed close. This is the new mantra, my friends. You either fix it right or you fix it wrong. And in some cases, if you fix it wrong, that's going to could cost them personal injury, or at the very least, a very expensive repair bill to recuperate from. So just keep that in mind, when you go to work tomorrow. That vehicle that you're working on, maybe that you never did this particular service, and I'm talking about simple stuff. Doesn't even have to be highly complicated. Changing a battery now again today, guys, is like you have to tell the car you changed the freaking battery. There's a lot of things on there that you may not know that you have to tell the car you did, but if you read the information, then you would, right?
That's correct. Very, very, very important. And by the way, if you can see this on YouTube and other places, when these Teslas catch on fire or any lithium battery goes on fire, I mean, they've had problems with the Boeing jets, with fires. The lithium battery has to be in a stable condition. This is why this is a tool that you're going to need.
Yeah, and you don't put those fires out with a fire extinguisher, bud.
Oh, no.
These things are, you run away as fast as you can.
Now, this looks just like a machine gun. There is no oil. Do not put oil in any high voltage battery or any high voltage component. Oil will deteriorate stuff, and then you would have a problem. So that is one type of tester. And of course, the bullseye tester with CO2, that connects to special plugs that fit in the battery. For example, I think I counted up all the ones you need for Ford. I think it's about $4,000 just in connection plugs.
Wow.
And probably more coming out as they have different batteries.
Yeah.
And same with Tesla. Tesla went through a whole bunch of styles. And at one point, Tesla was dropping batteries on a charge and go. They did away with that because what happened? Some of these batteries got a little bent up, a seal problem, and then you get a battery failure.
Yeah.
And again, these things are not cheap at all.
There's a whole new meaning to the phrase, Mr. Customer, you need a battery.
Yeah.
No more $199.95.
You know, here in New York, we're on California standards here in New York. So basically, it's 10 years, 150,000 miles. You may be in a 8-year, 100,000 mile state. Okay, if you're not enhanced emissions. And right now, believe it or not, the government, and we just seen this on the NASTF thing, the government is trying to set limits even on electric cars because of how they're made. So go to NASTF, like he said, www.nastf.org, sign up. You could also go there and see Tesla and other manufacturers, GM, Ford, whoever, Toyota. You can see all their first responder information that'll give you an idea. And notice that they're always going to tell you to have PPE. Do not touch anything without it. Okay. So here, the battery. What's the battery made up of? Well, so if we had the nickel metal batteries, Pete, now this is the older version that's still made with some cars. Of course, it's a lot less money, correct? A lot less money. But all of your full electric vehicles are only, at this point, going to have a lithium-based battery. And that's why these have to be cooled properly. So you're not going to use Joe Schmo antifreeze. You're going to look the spec up, and that antifreeze can't be mixed with regular water, or we'll have something called isolation faults. Same with air conditioning, okay? Oh, my machine has auto flush, okay, or hose flush. Well, what do we use most? R134A. And, of course, we've been using here R1234YF. Basic non-electric compressors are going to use what type of oil? That's right, PEG oil. PEG is an alkaline, okay? So if we have that, the windings could short out in the compressor and in some cases shut the vehicle down, or at the very least, shut the AC off.
Yeah.
Well, what does that mean? Oh, my battery's getting hot and I can't get to the next level. Does that make sense? What's the next level? Like getting off the road, like getting to where you want to go. So it is a different animal. And even when we talk about hesitations, electric car with a hesitation? No, it's not the APP, the accelerator pedal position, although it could be because it'll still have that to go send the command out to that battery. But we may have a capacitor issue. What do you mean? Well, we got to boost that voltage up. If that capacitor that we test with microfarads is not up to the specification, and you got to know what that specification is, it's usually printed on them, but you should all be aware of. Do you have a proper meter to test it? Do you know how to test them?
You know what kind of meter you have to have.
Exactly.
You know?
So we're going to talk more about that, but batteries by far are the heart of the vehicle, but it all starts with that 12-volt battery.
Yeah.
Basic stuff that is often overlooked is going to be the fix for the vehicle.
Yeah.
Okay.
Yeah.
Because we could have a 12-volt battery, and I'll give you a good example. So there used to be a company called the Hybrid Shop that I did a lot of work for. And besides doing training, we did a beta test here. And we used this Nuvant high voltage battery test and reconditioner. Make a long story short. All done for free. I got paid from the company, but we offered it for free. So we had all these people come in, and this one lady, Lauren, I never forget her name, okay, almost fired her, okay, because she got the battery for free, and these customers were told, bring in your car, please unload all the stuff from the car, have your car cleaned out. Well, we filled up the back of a freaking bay because she had so much junk in there. You know, she gave us, oh, I'm sorry, I didn't have time. Well, make a long story short, we reconditioned her battery. But of course, before we did that, as we're going to show you in a little bit on a Chevy Volt, an extended range vehicle that's right behind this car, okay, we're going to show you the battery cells. And we looked at the eye candy. What's the eye candy? The screen. How many miles a gallon should it get? Well, she was in the 30s. 30s, I'll buy a Hyundai, a gas engine, and not have a problem, right? And get 40 miles a gallon. So we put the battery, reconditioned battery in. We check everything out. We find the 12-volt battery's bad. So we write it down. We said, look, you're not going to get the right miles per gallon. And I want you all to think of it. What do you think is a problem? Okay. What do you think is a problem why she's not getting the right miles per gallon? Please type that in there. So this lady comes back, and I have a little rule. I get very cranky because I don't need to do this anymore. And
No.
she comes back one time, two times. I explain it. I retest it. I show her. And she's, no. My battery, you got to give me a new high voltage battery. No, we don't. You got to fix the problem. Any answers there, Pierre?
Not yet.
Okay. So basically,
Which is not a bad thing, guys. I mean, first, when was a delay, we don't expect to have all the answers. That's why we're here.
yeah,
So,
and it's
tell me
fine.
what you think.
By the way, there's still some complaints intermittently about your mic.
Really? But Doreen, not on our end.
No.
Yeah, I'm sorry. Maybe
Yeah.
too close. Let me move it down a little bit.
Now, sometimes we had this the other day as well, where some people, it's something with their sound. We had, in fact, it was like 4 comments. And the rest of the people I got on, it's not a problem.
Yeah.
It depends where you are, what you're connected to.
Yes.
We go out at a 1 gig signal. We got good mics. And in fact, a couple of people were breaking my news. You got good technical stuff, but you need good mics and stuff.
There were a few answers. None of them actually hit it exactly on the head, but the closest one was somebody saying, basically it's overloaded. It's doing too much work to charge the 12-volt battery.
Okay, so whoever said the 12-volt battery, yes, in this case, the 12-volt battery was weak. Okay, so what component is going to charge that? There's no alternator on the car, even though we said the motor generator is like an alternator, but there's no alternator like we have on a conventional ICE type car, right? So what is that component? We're going to be talking about these components. What is that component that's going to do that? And how in the world could that give her less miles per gallon?
Yeah.
So to finish the story, I said to her, look, this is the 3rd time back. You're wasting my time. I told you need a 12-volt battery, and Prius batteries are not cheap. They're in the vehicle, so it's an AGM 12-volt battery. I said, I'll tell you what, I'll make you this deal, and I'll put it in writing. If I put a 12-volt battery in your car and it does not increase your mileage, okay, I will let you keep the battery and give me your money back. She looks at me. Could you sign your name next to that? It's on my business letterhead. I was like, boy, you're really pushing it. But I did. And this lady, Doreen has met her. This lady is a piece. Okay.
Of work.
So of work. Yes. Okay.
This is a
family
PG show, right?
And I meant a piece of work. So nothing
My
derogatory.
mind's the one
Yes.
in the gutter,
Okay.
I'm sorry.
We put it in. She gets up to about 54 miles a gallon.
Wow.
And you know what? She's still accustomed to this day. Came back recently to ask me about another vehicle she has and another hybrid. Okay. What she should do with it. So basically, when you don't have an alternator in these electrified vehicles, whether it's a full electric or EV or hybrid, okay, don't matter. What you have is the converter. The converter is going to act as the alternator. It is going to basically be for the low voltage system. And that means even charging our battery back up. So we've done quite a few converters here, not a gazillion of, but a fair amount. 4 simple problems like that. And sometimes people go, oh, you had to have a code. Not really. Now, my buddy Bobby Grzinski, he is an ex-engineer for Ford Motor Company. His last job was Audi Volkswagen. And like Bobby will tell you, there weren't enough codes yet. And even though we went to P0A type codes for hybrid, we got 5 digits. We are now going to 6 digits because there is that much information. Yeah. This uses a whole bunch of different connectors that we were going to show you, but unfortunately did not get here in time. But the Chevy Volt back there doesn't have 1 OBD2 connector. It has 2. That's how much information and wiring and electronics are on these vehicles.
Yeah, and that's the game. It's just like when we look at the developments in the gasoline segment, they've become so extremely efficient now because we have the technology to very tightly monitor every facet of their operation. No, nothing. The basic engine itself hasn't changed. Right. And same with the electric car. The basic functions haven't changed. The technology has just grown to the point now where they're more efficient and they're able to do their job more effectively.
Yeah.
Now, I know one thing too, I'm kind of curious about, because we said we're going to take a look at the Volt. You shared with us in previous webinars, and that's the other thing I want to make sure I get in here before I forget. Now that you guys are signed up on the Motor Ace training site and you're watching this webcast, I encourage you to take advantage of the entire library that's now open to you, and go back specifically and look up the January 2022 webinar that we did with Provincial One on hybrids and
Oh, we
bringing
did.
hybrid
That's right.
service into
Yes.
your shop. So you'll find some great information there. And we have a few others as well. So please, avail yourself of the resource. Many of those webcasts, just like this one, are offered to you at no charge. Take advantage of that. But in that previous webcast, what I want to remember is, you explained how these batteries, again, that AA thing was a joke, but not too far off the mark, because these batteries are made up of individual cells, like the Prius batteries, individual batteries that are placed in series, right?
Some of them series parallel,
Yes,
like on these.
yes. So that we take that little 2-volt cell, like we do a 12-volt battery. You got 6 of those, so that gives us the 12. Well, if I got 50 of them, then I got 100, right? And so on. And that's how these things are built. Now, guys, what happens on a 12-volt battery when one cell gets a little weak, don't you? What does that do to the charging demand? What does that do to the battery? Now imagine you've got a whole lot of cells. Those numbers, that effect that they're got to be close to each other is a big deal, right? Now, you started early on with the Prius batteries, and a big thing
Honda
with those
batteries
was problems with corrosion in those connections. And
Correct.
you've shown examples of those. And you used to be able to recondition those batteries by taking donor cells from a battery that came out, say a salvage yard or something.
Correct.
You can't do that anymore, can you?
It's very difficult. First of all, trying to get donor cells now that the technology is out for a while. So batteries we used to get for a few $100, recondition them, clean all the bus bars up where the problems are, and basically discharge, charge, get it back, cycle the battery per se, get the thing back on the road. Now you can't do that. Now you'd need, a good battery, which means you may have to buy a new one from the manufacturer. And here, this is like AA batteries. When you look at Tesla, and they're going to go to a bigger battery, but currently these are like AA batteries, and there is a bunch of them there. Okay,
9,684 in them.
but a lot, probably not far from it. There's hundreds in there. And when you go back to the D size cell that they're going to switch over to, which is 1.2 volts per cell, you have that in Honda, the very first company that came out with the hybrid, and they use 6 cells in a stick, 1.2, that's 7.2 volts each.
Yeah.
Put it in a pack, which is 2 of those. So basically you're running 14, 15 volts. Now we're going to take a look, as we're speaking of batteries, about the 360 plus volt battery we have, no pun intended, in the Chevy Volt. Okay, so we're going to show you that probably right about now. If you just switch cameras, or
Is that still on, or you want me to turn it?
double check, Pierre.
That says your little connector blue. That's plugged in. So
Yeah, but we may have timed out.
So what we're going to show you is we're going to show you on the Volt, first of all, just how many battery packs the thing has in the battery itself. But one of the big service opportunities that you have to kind of start easing you into hybrid and EV service is checking the customer's battery. Like G said, that can be a cause of power complaints or low mileage from what they're used to getting. And many of the vehicles on the road now, they're outside of those service limits and are open for retail work, replacing those batteries on a retail basis. So how do you test them? How do you inspect them? How do you get an idea of what that battery condition is?
Because if the fingers work right, battery energy module. Okay, so we're going to take a look at, maybe I'll do it here.
Yeah, well, let's kick out the kickstand. There we go. And hey, I gotta give some props to the folks here at Snap-on too. We're using their tool, but you may not have seen this one before. This is the new Zeus Plus, just released, and it's got some really great features and benefits to the tool. So should make sure to check that out. We're going to show you just some of the things it can do here. Keep an eye on our YouTube channel, and I'll be showing some more of this here in the very near future.
And by the way, while you're looking at that, we're in a shop and it's, there's glare off the lights and everything. So it's not
so
as
you
good.
Okay, leave it right there. And just come in.
Right there you go, right there.
I had it good the first time.
That's fine.
Okay, so we're gonna go in. You see, you got that voltage data 1, 2, and 3. So watch what we got here. Now we're hooked up Bluetooth, and take notice that we have 4.6 volts per cell. And this is something you want to look at, battery balance. Now we go down to from cell 1 to cell 32, but that's only on one part of that battery. Okay, so let's go to data 2 here. And this is something you need to go in and check, because if we have something out of whack here, we got a problem with this battery. By the way, this battery is over $20,000 on that vehicle.
Yeah.
And it is a big T that you need a special cradle and not some piece of junk tranny jack to hold the cradle. You're going to need a good table to take this out.
Yeah, there's actually a tool for that.
Yep. So now here we're on cell number 64, and basically they're all, and here goes the last group. So now we go down and I can eyeball it, and we already looked at this for the sake of time. They're all 4.6, but could you see that total right there?
Yeah, that blew my mind.
98.
98, 96, 98.
Oh, 96, excuse me.
Yeah.
The
But
eyeball.
that's individual battery packs, and if it's typical construction, that's 2 cells per pack.
2 modules.
Yeah, 2
per pack.
modules per pack. And then
Yeah.
how many cells in the module?
Now,
You know.
yeah, this battery is a totally different design.
Yeah.
But I mean, if we go like this, just on that last cell, if you start graphing them all, you could see if you have a dropout in it, which is pretty damn neat. Okay. So you can start looking at that if you had any type of problem. And obviously you can graph as many as you would like, right?
Yep.
So we can go like this. And by the way, this screen is a lot nicer than my old Zeus, the Zeus Plus, because it seems to like my finger better. Okay. So you can see to max them in. And why is that important? Because if we have a battery imbalance, that vehicle ain't going to work right.
Yeah, I mean, think about it with the 12-volt battery that you're all used to, and gee, I'm a neophyte to the hybrid EV world, so you correct me if I make a mistake here. But if you have an imbalance, you have a cell that's lower than the others, then the battery control module is going to try to bring that thing back up where it needs to be, which is going to increase the overall charging on the rest of the battery. What's that going to do to the battery's temperature? It's going to increase the temperature. It makes it harder to control that temperature. And that puts wear and tear, accelerates the wear and tear on the battery itself. So being able, and of course that doesn't produce what it's supposed to. So it's not going to produce the mileage or range on the EV that it needs to. These are all things that you can help your customer overcome by simply scrolling through the data and see if there's an odd man or two out from where it should be. Now, in terms of what do you do about it when you see that? Well, again, that comes to what I said earlier. That takes more involved training to know what I can do a reconditioning on this one. And if I do, it's going to be done that. And what does reconditioning even mean? And, how can you, I know like in the Prius, for example, there's a few ways that you can do an actual loaded test on the batteries while you're monitoring. These are all things that, like I said at the beginning, before you run, you got to learn how to walk. And that's what we're trying to do here, is give you the tools you need to build your foundation on. Anything that we've ever done together or done individually, when we talk to technicians all around the country, invariably the weakness is in that foundation. The cracks are in that foundation. Let's get those built nice and strong, and then you can build your way up from that. So that's what we're trying to do tonight, to give you that foundation that you can start building on, and then continue your training, in this area.
Right.
Just like we said earlier, is if you go back to that alternate reality, you might know everything in the world you need to know about a gas engine, but now you're a baby. You're learning everything from scratch.
And let's not forget, with these cars with that 10-year, 100,000 mile or 150,000 mile, those things, what happens when this car gets old? So that Volt's a 2013. Well, hey, we're coming on 10 years. That means that battery goes, it's all on me. It's not on the manufacturer. Now, GM and other companies, Honda, I know dealing with Hondas for years, the first hybrid out there, they've gone over what they said they would cover it as customer goodwill. I do know a couple of my students winded up picking up a Volt, and the battery had an issue. General Motors basically ate a lot of crow on it to keep that vehicle on the road. That may look perfectly good. There's not a problem with the mechanical part, the engine, but this battery's dead. What do you do with this car? It can't start up. There's no starter motor. So what do you have? This beautiful car, that car out there was like 48 grand new, okay? What do you do with that? You just go, okay, battery's dead. I'm just going to leave it somewhere, go to the junkyard.
Yeah.
So there's going to be a market. But yet, if you looked at that vehicle in Kelly Blue Book or something, you'd go, it ain't worth putting a $20,000 in it. The car ain't worth 20 grand. So they usually work with the people to give them a decent price, because any negativity towards a hybrid, extended range, or electric vehicle is going to really hurt them. Okay.
Yeah.
That's why things are always sometimes played down.
Yeah.
We can go even with a Ford Escape hybrid. You had 2 fingers between the bumper. A 15-mile-an-hour accident hits that battery. That's near a $10,000 battery. Well, what did Ford do? They ate crow. They swapped the battery out. They wanted all the cells. There was nothing wrong with the cells. The case broke. And then they would redo it, recondition it, send it out, and do stuff like that.
Yeah. Well,
So-
it's the same thing too. If you're right now, some of the older Priuses, you can find a lot of them on the market pretty cheap, because the owner now is faced with a battery replacement, and to them, it's not worth it. So you can pick it up cheap,
Right.
put the battery in it, following the proper procedures and having your PPE on and so on and so forth.
And when they get a price
and
from the
turn it.
dealer, we've had many people come in and they may get a 6,000, 5,000, somewhere in that range price. And they'll go, I'm not going to put that money in here. We all get used to, like my Prius has 200 something thousand miles on it. Okay. We get used to driving the car, and we kind of get sick of the car, if you like me. That's why I have a lot of new cars. I get bored driving the same thing, right?
Yeah.
So when that happens, they're going to go, I'm not putting money in this car. And this is not like a Honda that had a regular starter motor where you can get by for a while. You got anything like a Prius, or what we call 2-motor generator, with no starter, you're done. You are cooked in the water, okay? We had an active hybrid BMW, probably about $150,000 car. You can read that article in Motor Age magazine, okay? And the battery, this thing was about this big, okay? That battery was super expensive, okay? That was a $15,000 battery without labor. And it ran off air conditioning and coolant. So now you're talking to labor to put it in, do all this. You know what that customer did? He decided to trade it into the dealer. What did the dealer do? First of all, it was a brand new BMW motor, because BMW had engine problems, although Pierre hates hearing that. Okay, so this active hybrid. And basically, they did put the battery in, probably cost them less money than they would charge me or charge a customer. And they winded up selling it. And they put the guy in a regular gas car. He's not made for that type of car.
Yeah.
And when I tell you a gorgeous car, it's a 7 Series. It is a gorgeous, the paint on it alone was amazing. Okay, and all the bells and whistles inside. But when you get stuck, is my point here, because a battery goes down or an electric component goes down, cha-ching, and in this case, that was a battery as well.
Yeah. But to play devil's advocate, when you look at an EV vehicle like the Tesla behind us, there's very little wear items in the powertrain.
Correct.
Right. So, you're not going to wear the electric motor out. You might have a failure, but you're not going to wear it out.
And they've become way better
Yeah.
with electric. We're going to show you these windings here, which is Star or Delta. Now, the new ones are like a threaded type that have better stuff. And I think I gave you that picture. Will be
Right.
coming up in a motor. So motors have gotten better. Converters have gotten better. Inverters have gotten better.
Yeah, but it's not like you're not wearing out piston rings. You're
No.
not having issues with the valve train. You're not this normal wear and tear that you have with it. I mean, an ICE engine that goes a couple 100,000 miles, we're doing pretty good.
Very good.
But like you said, you run a couple 100,000 miles, and that Prius is still going.
It's still going. And remember, that only uses gas some of the times,
Right.
depending on your battery level.
Right.
And that's why the battery is the heart. It is really the heart of the vehicle.
Cool. Next on the agenda.
All right. So let's see here. We have a DC to DC converter. Now, I do want to point out here, you see these tubes? Those are coolant tubes. And these are high voltage. This means PPE must be on when dealing with this. And if we have any coolant issue, oh, you used the wrong engine coolant. And you heard distilled water was the right thing. Well, you missed the webinar that Pete and I did quite a few years ago.
Yeah.
And we got, what type of water do you think goes in here? Not your tap water, okay? Deionized water. Now, I make it my business. We just got more antifreeze in to actually use the premix, okay? Because the premix is going to meet the spec on the bottle. And I can't remember what we paid, but I know that deionized water we bought that time
It's not cheap.
is not cheap. And not everyone has it. They're going to go, oh, you want distilled? Yeah, we'll send that to you. You make a mistake and do that, we're going to have an isolation fault.
Yeah.
And that means your vehicle is not going anywhere.
And guys,
It is a shutdown.
We've stressed this before. It applies to the gas engines as much as it does to the hybrid technologies. The days of being able to throw in whatever you want have been gone for a long, long time. You've got to use what the OEM specifies for their make and model vehicle. You just have to. And you can say, well, I've never had any problems using tap water before. Well, you've been lucky. Or do you really know that you have not had any problems? Okay, so your customer's water pump failed long before it should have, or the heater cord got eaten out. Let me ask you this. How many of you guys actually take the time to test your customer's coolant when they come in for a service? Well, what do you mean, Pete, test their coolant? Coolant doesn't last forever. And if there's so many different things that can affect the additive package in that coolant, deplete it way beyond its than it should have been. And that coolant can be far from being able to do its job a year later after it's been changed.
Yeah, but Pete, it's good for 20 below.
Yeah. You've got to check the pH level of
pH.
The coolant, and you have to do that routinely. And even more on these components.
Yeah.
Because of what it can result in. If it's, gee, please explain. When you say isolation fault, you've used that term a number of times. What does that mean?
Okay, so when you have an isolation fault, it is seeing a bridge, like an electric bridge that is shorting something out. To prevent a worse problem, it is going to shut down a system like air conditioning if you don't have the right equipment, or the whole vehicle.
So we're saying there's a potential for a high voltage leak to chassis ground that it's not supposed to have.
Right. Now, we have tons of examples that I use in my class of real cars that we worked on that had these type of problems. And some of them are not easy to actually figure out, but you get code dependent. Oh, got a code for it. Yes, you'll get a code for an isolation fault, but it ain't going to tell you how to fix it. Now, there's where service information will tell you to check things. And if you don't have the right tools, and you assume the ass out of you and me, you assume the right antifreeze or refrigerant is in that vehicle. Don't know. Just like when I worked on heavy duty trucks and school buses, we had the SCA, the supplementary coolant additive filter.
Right.
Okay. Because they use so much antifreeze in there that it would be horrendous. And the additive package, those spin on filters, are to help the life. You can do that pH level, and we've done this in a class, okay, with the little lipstick test. Yeah. See where you're at, and that could be the cause of your problem.
Absolutely. So the days of just relying on the universal stuff, again, in my mind as a tech, and always has been, universal means it doesn't work for anything. So again,
like that.
Use what the factory tells you to use for the vehicle, follow the procedures, and do these inspections. You're doing your customer a real favor, helping them protect their vehicle, whether it's gas or hybrid or EV, and help them get the most out of the investment. Again, we're looking at $15,000 or more for a battery. Well, they're relying on the cooling system and or the air conditioning system to maintain or control that heat. A lot of times they're separate systems, right, G? So
And they
it's
have a
not-
separate pump that you're going to need to check
right.
that inverter pump, which means it's going to go through the inverter, the converter, the motor. And what's always the big killer, even in a gas motor? Air.
Yep.
So you use something like Airlift or Snap-on's version of it, whatever you have to use. Make sure you get all the air out. We do that and use a burp funnel, especially when we are working on this. Because a converter's job, and you need to write this down, a converter's job is to take the high voltage DC and drop it to low voltage, usable for your OBD2 system, for your lights, for your infotainment system, brings it down to that level. And write this down as well. This becomes the alternator. This puppy right here is going to charge that 12-volt battery. We got to get that voltage back in there.
Yeah. So if I'm going to do a charging system check on one of these vehicles, whether it's a hybrid or an EV, let's see. Well, can I just go by the old 13.5 to 14.5 volt dealio, or
No, you can't. So, when we usually said with the older ones, well, lead acid battery 12.6, you should be at least a volt over. You can't go by that these days. And especially with this, there's the enhanced flooded battery, an EFB or an AMG. Well, that's on a regular gas car. Okay. Now you got an AMG or a flooded battery on.
You're thinking of AMC, brother. So it's AGM, right? You see the old AMC Matador, right? They used to always give. Just like a lot of you guys probably going like, "What the hell's an AMC Matador?" Well, we're just dating ourselves again.
Well, I also said to my friend the other day, "Yeah, you need an AGM." He said, "What?"
Yeah.
A glass bad battery.
We do these. If you haven't been here before, this is the norm.
Oh, well, sometimes the words, you see the brain not working all together, but you need an AGM, not an AMG.
Yeah.
Okay.
And it's and like you said, with the battery placements, anytime it's inside the passenger compartment, whether it's under the rear seat or in the trunk, it's mandated. It has to be an AGM style battery. You can't just throw it in there for the heck of it. On the EV and the hybrid side, it's critical that you read the specs for how these systems operate. Battery management and their charging strategies have become highly tuned, all back to what we said at the very beginning about trying to hit that CAFE standard of 54.5 miles per gallon by the 2025 model year. And you may see 17 or higher on initial startup. And we do this all the time. We see, it's amazing how many hands go up that we would be replacing alternators. Are you going to replace a converter because you saw that in the test? Just because you saw the test and you don't know what the spec's supposed to be? You're going by that 13.5 to 14.5 that you learned in the gas days? Again, guys,
doesn't apply here.
Put the reality back. If you're used to working on an EV and now you put this gas car in, it's like, well, I'm just going to apply that same EV spec to the no, can't do that. It's like I said at the beginning, the technology is just so far advanced now. I mean, there's more technology in the vehicles that you're working on that were on the space shuttle, and that took us, all over the place. And for years was a successful.
Oh, yeah.
Yes. And the stuff that's going on now, it's amazing the technologies you guys are dealing with. Like I said, again, the mantra now, guys, is when you go in the shop, you either fixed it right or you didn't.
Very true. So there's a converter. Okay. Now there's plenty of opportunities if you check, and you put it in.
Yep.
Now you're looking at this here is 2 600s and 1 750. This is a Prius, I can tell. Okay. A Gen 2 setup. You see that grid back there?
Now, this is the inverter. Yes,
this is the inverter.
Right? So, yeah.
Yep. So the inverter, Panasonic gives you the microfarads of how to test this. Okay. Now, of course, Toyota does not sell any parts for this. But you see the little coolant tank there? You see bubbles in there and you got problems. Yeah. So we don't want to see that. Now, what's the inverter's job? The inverter's job is to take that lower voltage, whether it be 460 volts, 400 volts, 201 volts, whatever the battery is, that's DC. It needs to boost it up here. So why do you have two 600 and one 750? Because the motor, the electric motor itself, is going to need somewhere like 600 plus volts AC. So its job here is with the integrated bipolar transistor is to take DC and convert it to AC. That way we get the power. Now, once we get enough of that power in the motor, you've all heard of regen. Now, I don't care if you're on a hybrid, extended range, or full electric.
And it's not diesel regen, guys.
You're going to get, right, you're going to get electrical regen going in. But I have a question for everyone. If your cup is full and you put more in your cup, well, it's going to spill over. Well, what happens to the voltage if your battery is full and you're going downhill?
That's a good question.
Okay. So it may be something you see on an L3 test, actually. Okay. But what's going to happen to that? We need to burn that off. Now, I'll give you this. When this is shut off, the 5 to 10 minute wait, you see that grid back there? That is to bring down the capacitors. This does not work to bring down the voltage as you're driving with regen to the battery. We're going to have to burn it up in the MG because you can't overfill the battery. And by the way, never think that that battery goes all the way down low and goes all the way up to 100%. I don't care what your car says. You look at scan data, everyone tries to stay, they don't like going under 20 in some car companies or under 40, okay? And they don't want to go over 80. Now, Tesla's like this, as you know, poor Florida just had, and thank God Pete just missed the problem where he is in Florida. But some people really took it hard down there. So our love and prayers go out to those people that really got affected, the Fort Meier area. In fact, I was supposed to be doing a class down there and obviously can't do it, right? But, even going over to what's Sanibel Island, I mean, that whole bridge is out, never mind Captiva. I don't even know if it's there. But that being said, what they did the storm before this last one, right through the cloud, and this is the way it's going to go in the future. They're already doing programming through the cloud. But what they did is Tesla said, wow, our battery level, we're going to make it is go down even lower to get these people out of a dangerous situation. Now, they left it like that for a while, and some people got used to it, go, hey, I got more range. That's not good for your battery, okay? And when we talk about the batteries on full EVs, okay, as you experience, level 1 is going to take a gazillion years, okay? So when you see some of those things on YouTube, the guy has a Honda little generator and it's plugged, good luck, you ain't going anywhere for quite some time. If there's going to be an alligator next to you, well, the alligator's going to eat your butt, okay? If you're out in the desert, well, you're going to get dehydrated because it's going to take quite some time, okay? Now, level 1 goes off 110/120, and it's really the best for the battery. Why? Because batteries like taking a slow charge. They don't like getting hit. It's like welding, right? Level 2 is 220/240. That is probably the most practical for everyone out there. I mean, I use a level 2 on my cars for the simple reason, the longevity of the battery. And it's realistic. If I plug it in at night, I'll have enough power in the morning. I'll be okay. Okay. Level 3, that's those big wires, the EVgo or SharePoint and all those companies. Now that is going in DC. The other ones were going in AC and gets converted going in through your charging point. The DC that goes in, this is only going to give you, number one, 80% of the charge. And it's going to take roughly about 45 minutes, 50 minutes. That's it. In fact, now they're starting to implement that at a lot of charge stations. And I know Tesla's doing this as well. If your vehicle is done, they'll send you a signal to your phone in case you're at the toilet or in a restaurant or whatever. But if you stay on, they're going to charge you. Because now someone else is trying to get there. And I don't know if you've seen these wires. Well, like the one you're going to connect to in a little while, that wire will not fit to the next car. Like you can't back it in and reach it. There's really no room on that, which brings into play when we have winter coming up, maybe the next time he comes back, there may be snow around. And if someone doesn't plow that spot good and there's too much of a snowbank, you're going to have a problem connecting your car to it.
Yeah.
These are things that sometimes, or people with a trailer pull in and they pull in the trailer. They're going to have to let the trailer down, okay, in order to plug in the vehicle. So there are some different things there. But again, level 1, the best for the battery, but takes too long. Level 2, probably the most practical. It's okay for the battery. It's not going to overheat it. And level 3, like when you go and if you hit the app that you're going to charge at a level 3, you go, where's my level 3 closest charger? It's right down the block. Basically, it's going to put your vehicle in a mode to accept that. It's going to help cool the battery down in order to accept the charge a lot better.
Yep. I already saw that little button. Yep.
So that's important.
Yep. And I always thought before I forget this, guys, when at least when I was growing up and first started driving, I was in the era of the muscle cars. We had like the Mustangs, the Chevelles, the Road Runners, the Hemis,
GTXs.
Yeah, all these big, muscle cars, and we were all like horsepower, right? Horsepower, that's the name of the game. In the EVs, if the EVs had run the world, we wouldn't be talking about horsepower. We'd be talking about kilowatts instead, because that's a measure of electrical power. And when you're looking at EV vehicles in comparison to see who's got the biggest, the hornies, you look for the one with the kilowatts, right? And that's something else cool about EVs. There's no torque curve to an electric motor.
Oh, they go.
Foot down, 100% right here, right now. Think of a golf cart on steroids. And having got a chance to play with this Tesla, I can attest to the fact that, it'll throw you back in the seat pretty strong. This ain't even the dual motor model.
Right.
So.
Dual motor and enhanced battery.
Yeah.
So there's two different things there. So
Any questions so far? I mean, we've kind of run it off quite a bit.
And like the Stellantis is doing away with their Dodge Challenger. The Hemi motor's going bye-bye. But what do they put in it? An electric motor's coming out and even has the sound like wah.
Yeah.
Pretty cool. Pretty cool.
That's good.
Okay, so let's take a look here at the electric motors.
Where the rubber technically meets the road.
So here, this is similar to a Volt setup, okay? But when you see this new style, like the pin type, compared to what we're going to be looking on, so there are different configurations. Motor generator 1, in this case, since it has 2, this only has 1 motor generator. But so did Honda. Okay, that was a 1 motor generator, and some Hyundais, some BMWs, some of the new Fords, they're just using 1 motor generator. Okay, so they're not using 2. These things spin over at about 1,000 plus RPM, somewhere in that 1,000, 1,200 range, off motor generator 1. Motor generator 2 is our traction motor. Now, these have had failures with these motors. The newer style here is a lot better than what we're going to look on the other one. You can switch to the other camera for a second. And you can see those motors there. I have one brand new one, courtesy of Dorman Products. Okay. So Dorman Products has made those motors and they've been tested. And the other one, which is closer to Pete's hand there, that looks like a smoke show because it was a smoke show.
Yeah.
And this was a high failure rate. And a lot of that is due to poor coolant. Now, what do I mean by poor coolant? Well, Pete, maybe that inverter pump, which was a high failure item, okay, the high failure item is maybe didn't cool that motor down enough. And what happened? Burnt up, okay?
And how many times have you guys seen a gas engine or a gas customer with a problem that is due to, I don't know, lack of maintenance?
That's basically,
again, it's the same kind of a concept if you're not taking care of it. And the other thing I want you guys to know that we're showing you some different examples. Like G pointed out, on a pure EV model, we don't need the 2 motor. It's the 1 motor generator, and they're also mounted differently because we don't have another powertrain we have to flow power through. We don't have to have it connected in any way, shape, or form to the ICE or internal combustion motor.
Right. And
we were talking about earlier, if you didn't know the difference, Tesla actually had a single and a dual motor model. And in fact, all-wheel drive would indicate there's a motor on both front and rear axles. And again, we put those 2 together and you add that more kilowatts, then it's pony get up and go.
And down the road, when I was over in Japan, They use motors at the wheel, which is going to be the most effective type of torque and regen.
Yeah.
Because now you got a motor that is rotating with the wheel rotation.
Yeah. So, I mean, and that's the technology, again, just like we saw in the gas days, it's all evolution of the technology. And we're already having a tough time to keep up with the gas side. Now we're going to throw EV in the mix.
Yeah.
So, yeah.
And it's always something to stay up, and we will adapt. In the days when we had points of condenser, we went to electronic conditioning, people were like, I'm getting out of here, right? And then when we went from that to computers, they're getting out of there. Drum brakes to disc brakes. You know what? We're mechanics. Yeah, I went out, and I never went to a high school for automotive. I learned on the streets of the Bronx, but then later on, I was like, well, I don't know a lot of crap. And things got a little more complicated. And lucky the guy I worked for at the time at a Esso station, he had a connection with the GM training center. Bless you. And that being said, I started getting into, wow, you can learn a lot of stuff by going to school, just like regular school, right?
Yeah.
And especially when you try it. As mechanics, like I said, we could read the magazines, we could look at the video and wish we can make those moves or doing it. Mechanics get good if you can show them, here's how to do it, and they do it. Practice makes perfect.
Yeah. And speaking of where to do it, it's like when we're looking at the motor generator, and it's really cool, guys, because when you break this one down into its simplest components, it's very simple in its operation. It's not like all the intricacies involved with a gasoline engine that you have to worry about. I mean, it's pretty much, it's either doing it or it's not doing it. And see, why don't you show us how that works?
Well, one thing I want to show you first is, you see this motor?
Oh, yeah.
So I want you to take a look at this motor very carefully. Now, this is not a hybrid motor. You can see is a brush part here on the armature, right?
Right. But
this was a floor grinder, but don't we have 3 phases of electricity here? And by the way, you see how that smoke showed up? This white stuff is insulation, okay? It keeps it away from the commutator bar. Now, this thing didn't have more than an hour, I'd say about an hour on it of use, okay? I was grinding my driveway down, and look what happened here. You see how this melted up? Something in the insulation was not made correctly. And what happened, it shorted from these windings here to ground and burnt it up. Now, this is no different than what we're going to see here. And we're going to do that live. We'll do it live, okay? Look at the burn marks on this motor. And I've done plenty. I got 2 more of these hanging outside. You see this is all burnt up? And these are all the insulators. Now, I've used this particular one in the class, but when we used to put the meg ohm meter on here, and we'll talk about that in a second, we would sometimes shut the lights off and you would see sparking or arcing, just like we've seen with the previous thing here.
Well, that must have been that smell we had earlier today.
Something smoke showing up, right? Well, hopefully that thing moves. But here, we're going to show you a comparison with a new motor, okay, compared to an old motor, and how to test it with a meg ohm and a milliohm meter. Because the tolerances got tighter, Toyota is the only one currently using it. Now, to be honest with you, I have never had a problem that I couldn't find on a motor generator. Okay. First of all, if you understand magnetism, we have a rotor that goes inside of there, right? Okay. And I could tell you if you got a motor burnt up simply by what God gave us. Your brain, your eyes, your ears, your nose, and especially your hands and your legs. Because when you push one, you're going to get... Why? Because we got a burn in there, and as that's going around, it's going to do this.
Yeah, and she's such a great teacher. And sometimes you got to say something twice for us, the little slow guys. So I want to kind of try to clarify something, and Jill jump in and tell me if I'm full of whatever.
So you're going to speak English to them, not Bronxese.
It's called, well, first the components, very simple. You're seeing the picture here of the stator. This is like you're used to on any alternator. It's a 3-phase, which means we have 3 windings. They might be wired in 1 of 2 different configurations. Really don't care. I just know that that's the stator of windings, and inside there's going to be this huge rotor permanent magnet, and it's a magnet, brother. Let me tell you, you're going to need special tooling if you even think that you're going to be able to just pull that out easily from inside that stator winding. But when the rotor is turning, that magnetic field, of course, is going to create the energy in the stator windings to send output to the system. That's when it's operating in its generator function. Now, on the other side of the coin is, if we send power through the stator and we do it in a certain way, we're able to alternate the magnetic poles in the stator, which reacts with the permanent rotor and gets that puppy to moving. There's actually a new component that you may not be familiar with. It's going to be this part of what we talk about in our November webinar. So mark that date down, November 19th. We'll be putting that information out pretty soon. That works the very same way. It's a brushless motor. Okay, so and it's just a matter of which way when we turn the juice on and when we don't turn the juice on.
And we got to use the juice up.
Yeah, exactly. And we got to juice it up in order to get that power. And that's, let's see. I remember that was the job of those capacitors in the inverter.
That's it. Look at that.
Okay, I learned something. Very good. Hope you guys are too. So, all
Okay.
right. With that said,
Switch over to that other camera, and let me just get this down here so it goes to the next slide when we need it to. And let's go over here. We have our bad motor, a good motor over here, and our bad motor here. First, we're going to use something, and I better walk around like this. Okay. Boing. So let's talk about a meg ohm meter. So our mega right here, we're going to put this on, and we should explain that we have this special piece right here that is going to go in here, and the other one here, and I'll just take both of these out so you can see that this is, I think we can zoom here.
There you go. Come back towards the old one.
There we go. So we have right here a negative and positive to put this in. And basically, this is going to be the trigger of that. I'm going to press this button, and I have it on 1,053 volts, but it's a 1,000 scale, 2.2 gig ohms every time I press this button.
And I would again stress to you guys,
We got batteries there. Maybe from this.
Maybe
I did put 1,000 volts out.
Which is what I wanted to point out. Everybody's watching. When he hits that button, anytime you're checking the resistance on anything you do electrically, checking resistance, the way it's done is that your meter is putting out a voltage and then using Ohm's law to calculate what the ultimate resistance is based on those numbers. Same thing here, but now we're looking like we would in a starter motor circuit that takes a lot of current. We're looking here at a winding that produces a lot of current. So we're going to use a higher voltage in order to test that resistance. But so when he pushes that button, he's literally applying 1,000 volts into that winding.
Yeah. Now I do want to go over one thing here. These are Cat 3 rated leads, but when this is exposed here, it is not Cat 3 rated. One nice thing with this lead, now that's Cat 3 rated. Okay, so watch what I do. I turn it off, and most of the time on a vehicle, I need to have it down. This little pin is sometimes very difficult to get on something. So I'm just going to leave it like this for now. This one doesn't have a pullback. It just has a cover, and I think you can see just a little pin type here. Yeah. Maybe let me put it here.
There you go.
So you see that little point? Only that point. This would all be covered. Okay, all be covered. And again, this one, that's a great picture.
Yeah, and the
This
stress
one
here,
has the
guys,
cover.
again, the meter is rated Cat 3. It's rated for use on a high voltage system, but the stress, you may have a meter that's rated, but if you don't have the leads that are rated, you're not ready to start connecting anything that's high voltage.
Or when I throw it in my Snap-on box, I close the drawer, and it didn't matter when a little nick happened over here on the lead if I'm using it on 12 volts.
Yep.
So never put your leads in a drawer. Put them in the locker like I do, okay? And that way those leads are never exposed to the drawer that, oops, can't see it from where I live. Well, that may be the last thing you see. It could be an electrifying experience.
Yep.
You don't want that.
And another thing, oiling, grinding.
Yes.
Don't want them coated with anything that's conductive.
Yeah.
That would be a bad thing.
Yeah.
Flammable.
Or flammable.
Yeah, you definitely don't want it. So here's what we're going to do. We got the 3 phases back here. I'll just lift these up.
There you go.
Okay. So now what I'm going to do is go between these. And like Pete said, these are connected. So what do you think is going to happen on this meter? Well, let's see. Notice we brought that all the way down. And watch what happens when I'm not connected to it. Okay. So we're not dropping that. Now let's do the other lead. Notice it's 0. Okay. Now let's go to the frame.
Well, you've got one more combination, my friend, right? We're doing UV, UW. We still got VW.
That is correct. And no matter which way we go, they're all going to be the same.
Yeah, and you're looking at those 3. Well, again, what we're testing is those 3 different windings. Yes, they're going to come together at a certain point, but now we've made sure that none of the 3 different pathways that they have has a problem, right?
Right, because these are all going to have, basically, this is no continuity between it.
Right.
Right?
Mm-hmm.
And when we see it like that, there is continuity. So now I'm going to go to the frame. Let me hold my hand this way.
So we don't want any of them shorting the ground for sure.
And I don't want to put my hand on the wire and get an electric shock. Okay. So notice we have an open circuit, right? Because look, if I go here, watch what happens. Oop. Let me put that there. And that beeping in the background is the scan tool.
Yeah.
So you see how that's 0? This is 0, any combination. But when I go here to the frame of the unit, this is like that armature I just showed you with the insulation inside here, this whiteness in the back. Probably a little hard to see. There we go.
Oh, yeah.
Okay, so you see all this? This is the insulation. Okay, so that insulation in the background is not shorted, or up here, okay, is not shorted to this. It's insulated from it, as it should be, right? So that's a good motor. Now let's take a peek at a bad motor. Let's switch over to this baby. Well, it does help if the meter is up.
Let's see. I think that. There we go.
Okay. Wow, and you can see a little spark then.
Now,
And now we
before
can.
you go to the ground, let me.
Well, I was going to go here. I was going to do the last leg.
Yeah, because we got to do the 3 pairs: the UV, the UW, and then the VW to check the.
And you can see they're all being brought down.
Yeah. So if you just looked at that test, like we looked at the last one, we know that the windings are intact, right? So let me ask a question to the people who are watching. Does that alone mean that this is a good stator?
And that's a very good question, by the way.
Alone? Because that's the same reading we just had on the brand new one.
Right.
Right. So is that a good reading? Are we good to go with this stator? Is that all we need to do? Any answers? Give it a minute because we know we have the delay.
We got a good old delay. So come on,
So
you guys know it.
And that's the question. Does that alone tell us that this stator is good or bad?
Nothing yet, Pierre?
Oh, come on, guys. It's one little.
Oh, there's a no.
There's a no. Okay. So this more should be trickling in then.
Yeah.
Yes or no?
No, there's another no.
Okay.
Okay.
So very good, because again, when you're doing this, it's like, I mean, I was telling G earlier, when way back when I started, I actually started in the motorcycle side of things. This is the same way we did Honda alternators and Honda motorcycles back in the late 70s, early 80s. It's very similar to the ones on my new bike. So it's no different. And it's the same motor. There's 3-phase alternator and 3-phase on some other motors coming, and just to get a little bit of buzz in there. Well, it could be from this 1,000 volts that we're kind of close to. But anyway, so you have to do 3 things. First, you're checking the continuity of each winding itself, and then we have to make sure it's not shorted to ground, right?
Yeah.
So that's the next test. Let's see what that does.
All right. So now we're going to go here.
See where that. And then... Oh shoot! So that's 0 resistance, no resistance to ground.
Not like we had here. I mean, we could re-show that here.
Yeah.
But if I had a good reading, should be this.
Yeah, we remember we had 2.2 giga
Yeah.
ohms.
Let's just do this. Let's show them.
Comparison. Yeah.
Let's show them up.
See, that's good.
See?
2.2 giga ohms.
That's
giga ohms.
right. And 1,000 volts being put out and nothing going down and
Nothing's leaking
shorted.
to ground, right?
But here, okay, so just tilt it a little bit the other way, Pete. There you go.
Whoop, there we go.
So you can see that's down. And if you look at this, I'll just shut this off so we don't hit the button.
And just say that any lead that we put this on, guys, would show the same thing, right? Why? Because they're all interconnected.
And look at the burns. So the black windings here, that all burnt up, all shorted, because just like we showed you before, the insulators here are burnt up like that picture on, you can click one back, on the slide. Okay, now that's a brush type, but it don't matter. Same thing. You see where the insulation is? Right there, burnt up. Okay, burnt up. So really, there's no difference. Now, something that Toyota came out with that so far no other company has followed them.
I got one more thing.
Okay.
Before we go to that one. We had 0 resistance. Motor burned up. Why? It's like Ohm's law, right, guys? 0 resistance, same voltage. What's going to happen to current flow? Through the roof. Through the roof. And what does that create? Heat. What does that create? Melts the insulation on the wiring. Now they come into contact with another and it just goes downhill from there.
Yep.
All
So
it takes is one.
now Toyota came up with a new specification, and if you actually go into Pro Demand, they'll give you the spec. Now, a lot of newer Toyotas, rather than 1,000 volts, this is a Gen 1 motor, by the way. Okay, both of these are Gen 1 motors, so replace Pete's out. Get a couple of new batteries. Sorry about that. As he's switching batteries out, okay, we will look at this. So Toyota came up with a spec on a meg ohm meter. Just put them in a spot we don't use them again.
Tell me they got a full charge on them.
Well, sometimes it lies. But at any rate, so Toyota would tell you on like a late model Camry, I looked up before, and I know it because we've just done a couple of them. It's 500 volts they want you to use it. Now, we found a wiring issue right to a air condition coming out of the inverter. We followed the test in Pro Demand, and it was not a problem. Okay. Well, good. No?
Anybody having issues with hearing, G?
Testing,
I don't hear
testing.
them.
It's
Yeah.
better. Well, actually,
Yeah.
I heard static again, so I don't know.
That's good.
Okay.
I'm good. Yeah, I got full bars. Okay. So they have a different specification. Now, something new they added, a milliohm meter. Okay. Not just a megohm meter, but now a milliohm meter. So let's see what type of test this is going to give us. We're gonna put this on.
So explain this to me. So now I know the mega ohm was like really high.
Right. Putting a high voltage out.
So the milliohm has got to be lower than low.
Lower than low.
Okay.
Very low. So watch this. So you're not going to get hurt putting any voltage out of here. We're going to go look at the new motor first. And we're going to check the phases. Remember, about 35 or 36. And by the way, the component should be cold, okay, which these are. 35, 36, go into the middle. 37, okay, so a little bit different there, right? And let's see if we went here. Yeah, so a slight bit difference, but now let's do the bad motor. And we're not going to ground yet, okay? 38. 31 and 31.7 million ohms of resistance. 33. So we got a slight difference. Now that's where RTA, if I read the specification, there is a limit. Okay. Now let's go.
Well, I'm going to, because I want to ask about that again, because we were talking earlier about maybe a complaint of power or change in fuel economy or something like that. You test the battery, and guess what? Battery's okay. You know, but now you're looking at this millivolt reading on these stator windings, and it would seem to me that if there's one that's outside the various allowed by the specification, that means that one of those windings ain't pulling its fair share of the workload.
That's right. And that's the thing. So they may be a complaint of a power problem. And Toyota has gotten down to this level of testing that.
Yeah. And I also want to ask too, because you mentioned this before we start testing the stators, that well, I hope didn't go by anybody. When G was talking about when you push the car forward and you feel that resistance, because what are you doing? You're turning the rotor, that permanent magnet rotor, and as you turn that, it's going to create what in the windings? It's going to create that voltage. There's a huge resistance in that. So if there's an issue, and you feel it stuttering, that's another good indication there's a problem there. It's also a warning, and you can't quite see it from where we are, but we have wheel chocks on the vehicle. We don't want to get pushed around while we're working on something on the system, because I don't want to get hit, with a problem, which is goes back to the safety we started the webcast out with, guys and gals. It's like, you can't play with this stuff. If you're working on the hybrid or even if it's just in the bay, you want to make sure that you use the precautions that we shared in the January webcast, that everybody in the shop knows. Here's my orange cones. You stay away from my work area. If it's a smart key, you put that somewhere way out of range of the vehicle. Yep. You have to follow these precautions so you don't accidentally create a problem for yourself, right? So,
no doubt. Okay, so we're going to do the last test here.
Now we go to ground, right?
Right. And now when you don't have something like anything with a meter, what do? You go play with the scales. Still nothing, right? Mm-hmm. Out of range. Out of range. Now we got a reading there we're on the 1,000 ohm scale, and it looks like between 1,073, 9 something.
Yeah.
Okay. So now it's like picking the pepper out of the fly do, right? And we can see we got different readings here. So something is worse in one than the other, right? It's a little bit different.
But now, all of them are going where they're not supposed to go, right?
We're going to get to that. So let's look at this. First, we'll go into our... Okay, we got nothing on all of them. And if we go just like we just tested there.
Yes, now you're on the lowest scale.
Yep. And we're reading nothing.
Yeah, so that's really good.
If we went back to here, and you see you got a reading, but we go up, we did that 30-something million, right?
Mm-hmm.
But once again, if we go ground to any of these, and we're going to do the same test We got nothing. Let's do that on here. Oop. 2000 scale. There we go. Okay, so you can see that these leads, I just took the meter a little bit to catch up, and again, go back here so you can see the difference. Leave it on there, and you could see that you have continuity there from the windings to the ground.
Now, G, in your own personal experience here in your shop in New York, I know you get a lot of hybrid vehicles in.
Yep.
What would you say in terms of service opportunity have you seen with these type of components failing?
We've seen a fair amount with them, especially generation 1 and 2 Priuses. Never changed a Honda IMA motor. They're pretty much bulletproof. We did a Ford that had an isolation fault, but they are also pretty well done. And all the new ones are very, very good because as we had in the picture there, the Volt type one pictured is wound different, okay? And it is a stitching type rather than this looping type, okay? So they've really done a better job on the newer type of motor generators than before. We've done converters, inverters, and again, not to knock Honda or Toyota rather, they're a great company, but the higher failure rate there. Even on my Nissan Altima that I have outside hybrid, we have an inverter problem on it, okay? And that is basically the same system as Toyota. That's like a Toyota Camry system. So those are the things.
Defense, they have a ton more on the road right now than anybody else.
Than anyone else.
Right? So.
But I must say that a lot of the problem is the inverter pump, the weak link. And doesn't that go back to everything being the basics?
Yeah.
Antifreeze, air pockets. If you don't
keep it cool.
Can't keep it cool, you're going to run into a problem.
Yeah, absolutely.
Any questions, Pierre?
No.
Okay.
All right. Well, we must be doing a great job.
Yeah.
Sorry.
That means we can almost retire.
Yeah.
Yeah.
Sure. All right.
And you could, when you shut it off, unplug it, Pierre.
Okay. So that kind of brings us to the end of tonight's webcast. We always hope that you guys and gals have taken a little something away that you didn't come here with before. And we always like kind of ask that, if you thought that the time you spent with us this evening is worth your time, do us a favor. Take that one little keystroke and give us a why. If for some reason you thought we didn't do that good a job,
we bombed, we sucked.
Tell us, type an N in there. We need the feedback as well, right? And of course, we got to make sure we thank the friends who made this possible. Of course, that's the folks at Mitchell One who made this available, this kind of training and information to you at no charge. And again, give them some props. If you're not using ProtoMan or there are other very valuable shop software, management software, by all means, check them out and take a look at them. Okay.
Yeah. I mean, we use that here in the shop. ProtoMan Mitchell One is very, very good stuff. And
sometimes even if you have a good service in your shop now, maybe you're using All Data, maybe you're using Modal Logic. They're good platforms.
They're all good.
But you know what? Sometimes one lies and one doesn't. Sometimes you want to have something you can go back and compare to make sure the information is correct. It never hurts to have different options. And if you do have any questions that show up after the webcast, and certainly if you watch this recorded later on and you have a question, there's our email addresses. We're not hard to find.
Nope.
By all means, reach out. We'll do everything we can to be of assistance to you. G, tell them
well,
all about
hey,
this.
TST next month, November 16th. We have Jeff Zide. He's doing some lab scope diagnostics. I'm not 100% sure of the name of the class, but I threw this together because Jeff just got back off vacation. He did a great job for us last year, and ATS, he works for them and really comes up with some good case studies. Our TST big event, Saturday, March the 18th, 2023. Everyone is going to get a table seat, but we're going to limit the amount of people. And the amount of people we're going to limit that to is about 550. It is our 20th year that Pierre, myself, started in the very beginning. Even before that, we were part of STS, but it's our 20th year as TST.
Wow.
So we will have out Gary Smith this year, Keith Perkins. They'll be our guest speakers. You'll see more. You can sign up pretty soon. Early bird gets the worm. That means you're going to get a discount. We're going to have a special speaker as well, and our friend Peter Cole will also give us an air conditioning update. This guy here, I volunteered him to be the keynote speaker. He didn't know about it, but I did it anyway. What the hell? But Pete has been a great supporter, and Motor Age as well. I want to thank them on behalf of TST. And then we have, I got to put a plug in for myself. We have about a seat or two left, but this is actually next weekend when I come back from Youngstown, Ohio, okay, teaching out there. I have my hybrid EV class, and we got people from Colorado, people from down south, someone from Connecticut. Sometimes people come from far and close, but it's a 3-day intense class. If you miss this one, not sure when the next one is, but it'll be coming up. And you got to eat your Wheaties and rest up, because I run you very, very ragged. We start at 7 in the morning, and I say 8:30, but we usually get out of here on Friday and Saturday, somewhere near 10 o'clock, and you got to be here in the morning. I watch my cheap Timex watch, and I go, time to go. And we take off Sunday. We make sure everyone's out of here at 4, because some people fly in from other countries or other states that need to get back. 2 full color books, high voltage gloves, high voltage covers, a bag, glove dust. And when we're done, you get access to, I think, about 30 or 40 hours of online training, because it's hard to remember everything. So I have some stuff that I've recorded during classes. I've had Pierre work with me. He's come through originally as a student, and he has been helpful working for me in the past on making sure people understand. We do some inside, then obviously the big part is here. And that's why, guys, once we get into the shop, they don't want to leave. So it's all good. We hope to see that. Pierre has a comment.
One question that kind of popped up. Somebody asked, what's an IMA?
Oh, very good.
What's an
very
IMA?
Good, very
Integrated Motor Assist. That is a Honda motor. So if you're a Jay Leno and have car number 2 of an Acura NSX, well, that has an IMA with a special 3.5 Nissan motor there. I mean, Acura motor, excuse me, and basically has 2 other motor generators that operate that car in a 2-point-something 0 to 60 range. So they're still being used.
Mm-hmm.
And when I mentioned the active hybrid from BMW, same thing. Brand new, police departments using Ford Explorers. Guess what? They got 1 motor generator as well. But Honda coined the phrase integrated motor assist.
Yeah.
So,
and this allows you to take some of the load off that ICE engine and let that electric motor help them boost up when they gotta go.
Gotta go and save gas.
Save fuel at the same time.
So my vehicle outside, that Chevy Volt, 158.4 miles a gallon.
Yeah. And stress too, to answer that IMA question, guys, the IMA motor itself is not a propulsion system like the Prius's motors are.
Right.
You know, it's like it's an integrated motor assist. And there are a lot of vehicles who adopt that. I think some of the Dodge trucks have that design now, and you're going to see more of that.
Yeah, that's called the BAS system, as General Motors first coined it. That's a big ass alternator on those. And basically that system is a help. It won't run just on that.
Right.
And Hyundai, Kia used it. A lot of car companies use that. A very inexpensive way to get more miles per gallon out of a vehicle.
So I'm good. So good. Good question. Thank you. Any others?
Well, there was one. Will the TST big event be at the same place as it was last year?
Yes. TST big event is at the Marriott Hotel in Terrytown, New York. Oh, and I forgot to say, we are having a big after party. So not only do we give you a hot breakfast, hot lunch, now you're going to have hot dinner. And then we're always looking for a sponsor to sponsor any type of adult beverages, because we can't do that from TST. So if you happen to be a sponsor or know of a sponsor, please contact us.
Give 'em a holler.
And we'll have a drink with you.
Please. Yeah. Like that open bar concept. Anything else?
No, I think that's it.
All right. So, hey, everybody, we really appreciate you coming out and hanging out with us tonight, as we always do. Again, we hope that you leave with something more than you came here with. That's the whole goal. And reach out to us. Again, I'm going to sound like a broken record, but I know that I can speak for Pierre, for Doreen, for myself, for G, and many of the folks that we've worked with. We really want to do what we can to help you make a better living. Again, make a bigger paycheck, take better care of your family. And right now, prepare for the technologies that are racing down the highway at you at light speed. So get ready for it, embrace it. Don't do like the guys of old did, ran away when they saw the first electronic.
By the way, I'd like to add something I've been using as a mantra lately. The 3 most powerful words in our vocabulary are, I don't know. If you admit you don't know something, 55 years in the business, I can say I don't know. You can too.
I always say I don't know. I got the G and half an O. If I had the other half an O and D, be God, know everything.
Yeah.
But we're not going to know. No one knows everything. Just please remember that.
Yeah.
Don't be afraid to ask.
That's right.
Yeah. All right. Well, that guys, thank you so much. We're going to sign off and wish you and yours the best. And make the date, November 19th. We'll be back once more time for our last webinar of the year. Until then, I'm Pete Meier. This is
G. Truglia. Thank you so much. And go Yankees.
Have a good night. See ya.
Okay, turn our mics off.
I'm going to move that out of the way. Is that coming back in here?
No, I'm thinking the bullhorn baby. Why don't you hop in the bull?
Do I